Okay, guys, let's talk about relationships involving delta H of the reaction. So when a reaction is multiplied by a factor, delta H of the reaction is multiplied by that factor. Because delta H of the reaction is an extensive property, that means it depends on the amount of matter. So let's look at these equations. So carbon plus oxygen gives us carbon dioxide. Well, when we double that whole reaction, 2 carbons plus 2 oxygens gives us 2 carbon dioxides. So notice here the H is negative 393.5, but when you double the reaction of the number of moles, that doubles the energy also. So if a reaction is reversed and the sign of delta H is changed, makes sense because this is going from a higher internal energy to, a lower internal energy, higher internal energy to lower, so it's releasing heat. But here we're going from a lower to a higher, so it's gaining heat, so you're going to change the sign. Okay? If a reaction can be expressed as a series of steps, then the delta H for the overall reaction is the sum of the heats for the heats of the reaction for each step. So if the reaction happens in multiple steps, meaning it A plus 2B gives us C, then that's delta H1. And then what happens is the C is going to decompose and give us 2D. That's delta H2. And so the delta H of the reaction is those two added together. This is called Hess's law. It says the change in enthalpy for a stepwise process is the sum of the enthalpy changes of the steps. So notice this one is going from a low to a high, so that's probably going to be a positive delta H, but then it's going from a high back down to a low, so that's probably going to be a negative delta H. So those two added together is going to give you your total. So it says find delta H of the reaction for the reaction. So we have 3 carbons plus 4 hydrogens gives us C3H8. Use these reactions with the known delta H. So this is how this reacts, or this is how it happens. So we have C3H8 plus 5O2 yields CO2 plus 4H2O. Has a delta H of negative 2,043 kilojoules. We have carbon plus oxygen gives us carbon dioxide, which is a delta H of negative 393.5 kilojoules. And then we have hydrogen plus oxygen gives us water. So this reaction, in order for this reaction to occur, there's several different reactions that happens, and those are these reactions right here. So it says to work this and other Hess's law problems, manipulate the reactions with the known delta H's in such a way as to get the reactants of interest on the left and the products of interest on the right and other species to cancel. So we know that we want this C3H8, we want that on the right, okay? And we know we want carbon on the left and hydrogen on the left. So when we switch those around, something's going to happen to these delta H's. So the first reaction has C3H8 as a reactant, and the reaction of interest has C3H8 as a product. So reverse the first reaction and change the sign of H. So we reverse it to where C3H8 is a product, but remember you got to reverse that sign. Now it says the second reaction has a C as a reactant and carbon dioxide as a product, just as required for the reaction of interest. However, the coefficient for C is 1. The reaction of interest, the coefficient for C is 3. You need to multiply the equation and its delta H by 3. So here, you'll see that we have 3 as our coefficient. And so we've got to multiply this entire reaction by 3. And that also means we got to multiply the delta H by 3. Now we don't change the sign because we did not flip the reaction. So the third reaction has hydrogen as a reactant as required. However, the coefficient for hydrogen is 2, and the reaction of interest, the coefficient for hydrogen is 4. So To get that, we multiply the reaction and delta H by 2. So here we multiply the reaction and delta H by 2. So it says rewrite the 3 reactions after multiplying through the indicated factors and show how the sum of the reaction of interest. Delta H is for this reaction of interest is the sum of delta H's for the steps. So we reverse this first reaction. 3 CO2 plus 4 H2O yields C3H8 plus 5 O2. Then we have C3 or 3C plus 3O2 gives us 3 CO2. And then we have 4H2 plus 2O2 yields 4H2O. Okay? Now notice what they did here. They canceled stuff out. Okay? So we have 3 CO2 on the reactant side and 3 CO2 on the product side. Now we have 4 waters on the reactant side, 4 waters on the product side. Now notice this. Oxygen, we have 5 over here, but we have 3 and then 2. Well, 3 plus 2 is 5. So they're still going to cancel out because you have 3 oxygens and then 2 oxygens. So once they cancel out, you get 3 carbon plus 4 hydrogen yields C3H8, and the heat of the reaction is 105 kilojoules. Okay, so to find the delta H for the reaction, again, you got to make sure that N2O is on the correct side, NO2 is on the correct side, and 3 NOs on the other side, and that they have the correct coefficients and such. Okay.